Welcome, infrastructure admins. You're tuned in to an in-depth exam prep explainer, and today we are zeroing in on a massive topic, NCP-MCI 7.5, Objective 7.3, Storage Policies in Prism Central. We're going to completely unpack how you can govern storage intelligently at scale, and we're doing this keeping the baseline of AOS 7.5, HHV 11.0, and Prism Central 7.5 strictly in mind. So grab your notes, get comfortable, and let's get you completely ready to crush this certification. Here's our quick blueprint for today. We'll start with why storage policies matter, move into categories and attributes, and then break down the default policy. After that, we'll look at compliance, uncover some tricky exam traps and edge cases, and finally, wrap up with the key facts you absolutely have to memorize.
All right, Section 1. Why storage policies matter, specifically looking at the shift to centralized management. Now, before we get deep into the weeds, let's quickly set our baseline with these critical acronyms. You're going to see these constantly on the exam and throughout this explainer. If you've spent any time in a Nutanix environment, you already know PC for Prism Central and AOS for the Acropolis operating system, basically the absolute brains of the operation. We're also going to heavily reference AHV, which is the Acropolis hypervisor, CVM, the controller VM, and of course your standard VM, and VG for virtual machines and volume groups. But honestly, the most important one to keep top of mind for this specific topic is RF, which stands for replication factor.
So what's the big deal here? Well, the crucial point is that storage policies allow you to systematically control data availability, security, and performance across all your VMs and VCGs using categories. You aren't doing this manually anymore. Just imagine you're tasked with deploying, say, hundreds of database VMs. Instead of clicking into every single individual VM to set compression and encryption, which, let's be honest, it's exactly how manual mistakes happen at 2 in the morning, you just define an intent-based storage policy right in Prism Central. You assign a category to those VMs, and bam, the system handles the rest seamlessly. It ensures uniformity, it guarantees compliance, and it totally removes the manual overhead. This massive shift from reactive, click-driven configuration to proactive, intent-based management is exactly what Nutanix expects you to understand deeply for the 7.5 exam.
Moving right along to Section 2, Categories and Attributes, focusing on the actual policy mechanics.
Let's look at how this plays out in your infrastructure. Within the broader Prism Central framework, storage policies sit right alongside your familiar VM, image, and security policies. But here is what you really need to grasp. A single storage policy relies entirely on assigning specific categories to your entities to enforce those attributes. It's brilliant, really. You create the policy and you tie it to a category, like Tier 1 database or, dev/test. From that exact moment on, any VM or volume group tagged with that specific category instantly inherits the defined replication factor, encryption settings, compression type, and QoS limits. It's a totally decoupled architecture. The policy dictates the what, and the category dictates the where.
Okay, Section 3, the default policy, featuring a PC.2024.1 walkthrough. This is a major focus for the 7.5 exam, so pay close attention here.
When you spin up Prism Central PC.2024.1 for the first time and head over to the policy engine, you're greeted with this really neat native UI prompt introducing the default storage policy. This specifically shows the standard configurations that get automatically applied when you enable the default storage toggle during a VM or VG creation. It's essentially designed by Nutanix to give you a really strong, sensible baseline of the most common storage configurations. That way, you don't find yourself needing to build a custom policy from scratch just to get standard day-to-day operations off the ground.
Now, let's contrast the rigid baseline of that default policy against the flexibility of a custom policy. These exact values are highly testable. Notice the specifics here. The default policy automatically sets the replication factor to 2, compression is set to inline, and encryption is set to inherit from cluster. But, and this is a big but, notice that it does not set any quality of service values, 0. Why is that? Well, because QoS is incredibly workload specific. It really shouldn't be blanket applied across a general default tier because doing so could artificially bottleneck your standard VMs. When you flip that toggle switch during creation, the system associates the entity with a special system category called storage.default. And remember this for the exam. You cannot edit or delete this default policy, though you are totally allowed to clone it to use as a starting point.
Watch out for this one. It is an absolute classic exam trap. Let's look at a concrete example of precedence.
Say a junior admin enables the default storage toggle on a new VM, which gives it that standard baseline we just talked about. But then they also tag that exact same VM with a custom category, let's call it High Performance DB, which has a highly tuned custom storage policy attached to it. So what happens? The system has to decide which rules to follow. Well, the rule of precedence dictates that the custom policy always wins. The non-default storage policy gets total precedence, and the default policy is essentially completely ignored for that entity. It's designed this way to protect your custom performance and availability requirements.
Section 4. Storage Policy Compliance and Tracking Application. Because, as we know, just because you assign a policy doesn't mean the data instantly transforms by magic. The compliance engine in AOS applies and tracks storage parameters in this exact, strict order of priority. Think of it kind of like Maslow's hierarchy of needs, but for your infrastructure data. First and foremost is replication factor, which guarantees your base data availability. Frankly, if your data isn't available, absolutely nothing else matters, right? Second is encryption, locking that data down. Third is compression, optimizing your space. And finally, throughput, which dictates performance. The system literally transforms the data sequentially down this specific list. Now, there might be edge cases where compression just isn't possible for a specific entity because of its underlying data type. In that scenario, as long as the replication factor and encryption are applied successfully, the compliance engine will actually still report the overall state for the entity as compliant. It's smart enough to know the difference between a real configuration failure and just a natural data limitation.
All right, Section 5, Exam Traps and Edge Cases. Certification exams love to test constraints and boundaries, so let's dig into the exact edge cases you need to navigate. Here is our second concrete example, and this one deals with physical limitations. Imagine you push a custom storage policy requiring a replication factor of 3 down to a VM. However, the physical cluster sitting under that VM only has a fault tolerance domain supporting an RF of 2, like maybe it only has 3 physical nodes. Well, you can't magically create 3 copies of data out of thin air if the hardware fault domains simply don't exist to support it. The underlying why here is purely a physical limitation. So the system will apply what it can, maybe it'll apply the compression and encryption settings, but it will flag the overall status as realized but non-compliant because your policy's intent is demanding more than the cluster's actual physical capability.
Now, if you see a scenario on the exam asking about a delay in compliance realization, you really need to understand the back-end synchronization process. Picture this. An admin applies a policy, checks the dashboard 5 minutes later, and sees it stuck on in progress. Panic sets in, right? They think something is broken, but it's actually working exactly by design.
That magic number to remember is 6. It can take up to 6 hours for that in-progress state to update to compliant or non-compliant. Why? Because the compliant state relies entirely on the curator service. That's Nutanix's background MapReduce framework that handles cluster maintenance. Curator only synchronizes extent groups to evaluate policy compliance during its full scan intervals. And those full scan intervals happen, you guessed it, every 6 hours. So depending on exactly when you apply the policy relative to the next scheduled scan, you literally just have to wait for that background job to do its thing and report back to Prism.
Beyond delays, you also have strict edge cases that trigger immediate noncompliance. First up, storage policies are heavily tied to Nutanix's native stack, meaning they exclusively require the Acropolis hypervisor. If you try this on an ESXi or Hyper-V cluster, it's going to fail. Second, watch out for category overlap. If you assign multiple categories with conflicting policies to a single VM, only one applies. The others will instantly report as non-compliant. Third, you cannot use these policies to set a replication factor of 1. Only RF2 or 3 are supported to ensure data integrity. And finally, a massive edge case. If your underlying storage container uses erasure coding, policy-based RF configuration is just completely out the window, because erasure coding fundamentally alters how parity and data striping are handled outside of standard replication factors.
Finally, Section 6, Key Facts to Memorize. Think of this as your ultimate exam cheat sheet. We are in the home stretch. Let's lock in these core concepts.
If you remember nothing else, lock these 4 facts into your memory right now for the test. 1. The immutability of the default policy. Remember, you cannot update or delete it, you can only clone it. 2. The precedence rules. A custom policy will always override the default storage toggle. 3. The synchronization timeline. It takes up to 6 hours for compliance states to update purely because of those curator full background scans. And 4. The strict hypervisor requirement. Storage policies are an AHV-only feature, no exceptions.
As we wrap up this explainer, I want you to consider how mastering policy-based management completely transforms your daily workflow. You are moving from reactive clicking to proactive infrastructure governance. By assigning categories, you guarantee consistency at scale. So ask yourself, as your infrastructure grows from tens of VMs to thousands, are you going to be the admin drowning in late-night manual configuration tickets or the architect seamlessly governing an autonomous cloud? Good luck on your NCP-MCI exam. You've got this, and keep learning.